Ooh, no. Like, put it back to histogram, then put some colour into it, rather than having it in grayscale. Anything.
These violets.
Oh, check that out.
Alps.
They're the pillars, aren't they?
And the pillars. Very good.
That one brings me quite nicely.
Let's go back. Let's try that.
As is that one.
20 seconds.
And that one too.
Rainbow.
Cool.
30 seconds. 30 seconds.
Yeah, that's
in
cool.
D, and then try 30 seconds in R.
Grab it and put it that one.
Nebula.
No, as in like the,
Rotate it.
the scale.
Oh, that one was taken.
Yes. We're doing
No, like
really
the
is the R one.
actual...
Aha!
Make sure you're doing it right way.
30 seconds in R after this, and then might stretch it a bit more.
Oh yeah, I get it now.
Not bad in the center.
Oh, cool.
Okay, are we happy with that? So let's try the R, and we can get back to the V.
Soft DB, I think was a nice one. B. B was nice.
My name is Mark Kennedy. I'm a final year student of Astrophysics in University College of Cork, and I'm from Tramore in County Waterford. Now, last night we were using the IAC 80, which you can see behind me. It's an 80 centimeter optical telescope, and I was using it to study the Eagle Nebula. The Eagle Nebula is a diffuse cloud of hydrogen gas, roughly 6,500 light years away from Earth. And basically there's 3 columns in it, called the Pillars of Creation. These columns harbour a lot of hydrogen and also some carbon, and they're where stars are born. So in the very centre of these clouds, you get an awful lot of pressure pushing a lot of molecules together. And when these molecules become dense enough, you start getting fusion, like happens in our own star. So when we look at a nebula like this, we see a lot of bright young stars in the exact middle. Now, the very interesting thing about the Eagle Nebula is that we think it's collapsed. And since the light takes about 6,500 years to reach us, we see it as it was 6,500 years ago. Today, it's more than likely not there. We want to study something like the Eagle Nebula because it tells us an awful lot about the origins of not only our own star, but our own solar system. Because if we want to find out where planets such as the Earth or Jupiter or Saturn came from, we need to first of all figure out what happened at the start of a star. Is it just on its own in the middle of a cloud of gas, or does it have a load of other dust and gas around it that it eventually brings down into a plane and compresses into planets? So they are the reasons why we'd study something like this. So my plans after I've graduated aren't set in stone yet, but I would like to do a young graduate trainee program with the European Space Agency. This is where they take on a student for roughly a year, they give them a project working on one of their space telescopes or doing data reduction, and they pay their costs of living for a year. So it gives me something nice to do to tie over between finishing my degree and maybe going on to do a master's or a PhD. This week has been absolutely insane. When you get here, you are completely speechless, the views take your breath away and continue to do so for every single day that you're here. As for observing, you always see pictures of nebulas or galaxies popping up on the internet, but you always believe, maybe they're a bit fake, maybe they're a bit photoshopped. When you take them for yourself, the feeling is incredible because you see exactly what they are like on the internet and you realize, wow, this is what the universe looks like.